All right, so at the top, we're going to do piecewise functions. So go ahead and give your notes a title. Piecewise functions. All right, a piecewise function is a function made up of pieces of other functions.
Wait a minute now.
A piecewise function is a function that is made up of pieces of other functions. So it might have one part of it that is linear and one part of it that's quadratic. It might have one part that's quadratic and one part that's cubic. You might have a little piece that is absolute value and another piece that's quadratic. It's a mixture. Typically at this level, since you guys are in Math 3, we'll do like a little piece that's linear and a little piece that's quadratic. That's the most common combination at this level. But it really truly could be anything. All right, so the more advanced you get, the more complicated your piecewise functions get. Each function is graphed for a particular interval. So it might be that the linear function gets the left side of the graph and the quadratic function gets the right side of the graph. So we've done them individually, now we're looking at what happens when you start to mix them up. All right, so we're going to go ahead and do an example. And when you do these, the instructions will just tell you to graph it. They're not going to give you much more information than that. So this is one of those like squiggly parentheses. So it's saying y equals x plus 2. What type of function is that, x plus 2?
What?
It's linear. It's going to look like a straight line. This is y equals mx plus b form, right? So you have a slope of 1 over 1. You have a y-intercept of 2. So we're going to graph that linear function if the x value is less than 1.
Wait, what is that in front of the x?
I put 1 over 1 for that rise over run. Since there was no number there, then the slope would have been 1 over 1.
Wait, did you just write?
Yeah, because 1x is the same as just x. You can write it or you cannot write it. It doesn't matter. They're the same.
Okay.
Yeah. So x plus 2 if x is less than 1, or x minus 1 squared if x is greater than or equal to 1. So when you draw the graph, one part of the graph is going to be linear, a straight line. What's the other part of the graph going to be? What kind of curve? We know what this is. Parabola, yeah. Part of it's going to be U-shaped. All right. So for this next part, you need to be writing in pencil because we're going to draw stuff and then erase part of it. So see if you can borrow a pencil from someone. If you just need to borrow somebody's pencil to do the erasing part, that's not a huge inconvenience. So borrow some pencils. You need a pencil. So first we're going to graph the line x plus 2. How do we start graphing that? Start at 2. Up 1 over 1, up 1 over 1, up 1 over 1. And I'm doing this part light because I know that I'm about to erase half of it. The line can only show up on half the graph. So what we want to do is we want to see where the line is less than 1, because that's what it says. It says you can only have the line if the x-coordinate is less than 1. So I'm going to go on my graph, and I see that the x value is 1 right here, so I'm going to draw a circle there. So if we want to keep the line where the x value is less than 1, are we keeping the left side or are we keeping the right side?
The left side.
We're keeping the left. So I'm going to draw the left side darker because I know I'm keeping it. Make it so it's easy. And then the right side gets erased. Now, it says that the x is less than 1. It does not say that the x equals 1. And so that circle right there, I'm going to leave not filled in. I'm going to say that that point is not actually on the graph. You can have x values like 0.99999 is okay, but an x value of 1 is not. So I'm going to leave that open so I know that that point does not actually exist right there. Okay, then it says the parabola x minus 1 squared. Can you put your phone away, please? Thank you. X minus 1 squared. So we have a parabola. I'm going to go ahead and write down my points because we're graphing this by hand. So here's my points for a parabola. And what transformation are you going to do to those points? Yeah, you're going to move them all to the right one. So go ahead and take each point and move it to the right one. What's that going to change about my points? Yeah, I'm going to take the x coordinate and add 1 to it. Are there any other transformations? Okay, so I'm going to go ahead and graph those points now. So negative 1, 4, and then 0, 1, 1, 0. Okay, so there's our parabola. And it says you only keep the parabola shape if the x value is greater than or equal to 1. So on the parabola, we're going to circle the dot where the x value is 1. Where would that be on the parabola? The vertex, yeah. So if you look at the vertex, that's where it had an x coordinate of 1, right there. And if it says x is greater than or equal to 1, are we keeping the right side of the graph or the left side? I'm keeping the right side, so I'm going to make the right side nice and dark so I can see it. And then the left side gets erased. And it said it was greater than or equal to 1, and since it says equal to 1, we're going to go ahead and fill in this dot right here. You can actually equal 1 right there. So that is our piecewise function. A piece of the line, a piece of the quadratic. How do you guys feel about that so far? Do you feel okay? Like, yeah, it's a little too literal, piecewise. Yeah. All right, so we're going to evaluate this because that can be kind of interesting as well. So we're going to evaluate this for f of negative 3. We're going to find f of positive 1, and we're going to find f of 2. So we're going to evaluate it for 3 different numbers. So what this means is if you plugged negative 3 in for x, what would you get for y? So if I look at the x coordinate of negative 3, what is the y coordinate? Negative 1. So right here we have a point, negative 3, negative 1. So that's why when you evaluate it for negative 3, you get negative 1. What happens when you plug in 1 for x?
You get 0 because you can't actually be linear graph.
Yeah, so if you look at where the x value is 1, you've got 2 spots, and this is where we said we actually can equal 1, and this is where we said we can't actually equal 1. So we ignore this one up here because it's not part of the answer. We look at this one down here and we say that's a y-coordinate of 0. So we have 2 places where the x value is 1, but this one it says you can't actually equal it. Since that dot is not filled in. So we can't use that one, we have to use the one down here. So the y-coordinate there is 0. That 0 does not need parentheses. That was me being silly. Okay. And then the last one, what do you get for y if your x value is 2? You get 1. Okay.
Wait, so when you do that, does that go for like those doubles?
If I look at the x value of 2, x value of 2 is only on the quadratic.
Alright, so like if you plug in, or if you look for the x value of 1, and it's, so like,
It
you're looking
shouldn't,
at both, right?
it shouldn't be on both because then it wouldn't be a function anymore, right? Remember, functions pass the vertical line test. That means if you pass your pencil through, it only touches 1 point at a time. Now here it touches 2 points at a time, but one of them doesn't count.
No, I'm not trying to say, it's kind of hard to say. I can't really think of what I'm trying to say.
Well, you're asking like, is there a point where the x value could be on both of them?
No. I'm trying to say, when you're looking for the function, it's not always going to be on one line. They're going to be on different lines.
It could be on different lines, yeah. So anytime you have an x value that's less than 1, it's going to be on this line that you're looking for the answer. Anytime the x value is greater than 1, you're going to be looking over here.
Okay.
Yeah. Okay. Any more questions on that?
Can you do a similar thing if you just told to evaluate an old function and you just plug in the function?
Yeah, yes, you can definitely, and we're going to do that on the next one because I'm going to pick numbers that you can't see on the graph. And we'll practice it that way too. All right, so example 2, we're going to do y equals -3 if x is less than or equal to -1, and -x squared plus 4 if x is greater than -1. You just don't need to. I mean, because having the little squiggly parenthesis on each side means something else in math. Having it on one side means that you're saying that y equals this list of things. And we're going to start off doing piecewise functions where there's only 2 pieces, but functions can get kind of complicated, and in college you could do one that has like 17 different functions. Yeah, there's a point where you'd probably use a computer to graph it for you, honestly. But so we're going to, when we start off teaching you piecewise functions, we usually just have 2 or 3. But you definitely could get to the point where you have tons of them, depending on the situation that you're talking about. So, all right, so if we look at the first one, if you think about the equation y equals -3, just y equals -3, what type of equation would that give you? Or what type of graph would that give you? Straight line. And it doesn't have an x in it, so it's not a slanted line. It's either perfectly vertical or perfectly horizontal. Do you know which one it is? Horizontal. Yes, so we're going to draw a horizontal line at -3. And it says that we only use that line if the x value is less than or equal to -1. So where should I draw my circle? Yeah, so I've got an x value of -1. I draw it right here. Should I fill in that circle?
Yes.
Yes, because it equals less than or equal to -1. And then which part of the graph are we keeping? The left side. What was your question?
Is this basically like those graphs that we have to shade in? Like just like
The idea is kind of the same, yeah, where like if it can equal it, that's where the shading is, but in this case, that's where you fill in the dot. And if it can't equal, you don't fill in the dot, yeah. It was reminding her of the inequality graphs we did before with the shading. It'd be like solid versus dotted lines, kind of. So if you can equal it, you fill it in. If you can't equal it, you don't fill it in. And then this is a less than sign, which is why we're using the numbers that are more negative than -1, or less than -1. All right, so that's what we have. And then the other graph that we have is a quadratic again. So I'm going to go ahead and take my points. And what are the transformations that we have to do to those points? What are the transformations that we're going to do to those points?
First one or the second one? No.
So not the first one because we're graphing the quadratic, right?
So the first one graphing, the second one is the other.
Say that again?
The first one is the one graphing, the second one is the one with transformations.
Well, no, so we graph both of them,
Yeah.
but I have to do the transformations on the point so I know how to graph that. So what transformation do we see first? Reflect over x. So what does that do to your points?
Reverse on the Y.
Yeah, so the y coordinate is going to change signs. And then what's our other transformation? Up 4. So we need to take all the y coordinates and add 4 to them. Mm-hmm.
On the first one we did, it was right one. What's the difference between right one and like left 4?
So this one had parentheses, and so inside the parentheses tells you left and right. You do the opposite. This one did not have parentheses, so we knew that number was up or down. Okay, so we've got -2, 0, -1, 3. All right, we got our parabola. And then we're going to go ahead and draw the circle where x is -1. And should we fill in the circle or leave it open?
Open.
Leave it open because you can't equal it. And then which part of the graph are we going to keep?
Right side.
The right side. So everything greater than -1, that's the right side. That means the left side can be erased. And we're going to plug in -50 and -1 and 17. So if you want to plug in -50, that's clearly pretty far off your graph. So if you were to plug in -50, does that fit an x that's less than or equal to -1, or does that fit an x that's greater than -1? Which one would -50 go into?
Greater than.
The bottom one.
-50 is way more negative than -1, right?
I'm at-
So it would be less than -1,
Yeah.
right? -50. So -50 is more negative than -1, so it would be to the left of -1. So we have to plug it in here. And do you guys see how there's no x to plug in? It would just be -3, yeah. So any number you have that you're plugging in that's less than -1 is just going to be -3 for every single one of those. What about if we plug in -1 exactly? Yeah, so we can see -1 is here and here, but this is where it does not equal -1. So we're going to use this one right here. That's a y-coordinate of -3. And then +17 is the other one we want to evaluate. So which one are we going to plug that into? We plug it in up here, or we plug it in down here? The second one, because 17 is greater than -1. So we've got negative of 17 squared plus 4, so -285. How you guys feeling so far?
Not too good.
Not too good? Not enjoying these? So basically, what's the process we've gone through?
You gotta grab
Yeah, draw the whole thing, draw a sketch of the whole thing, and then what do you do?
the chart. Or then you gotta figure out like which one you're gonna erase.
Yeah, so we drew a circle at whatever the number was so that we could know if we should keep the left side of it or keep the right side of it.
Wait, so when do you decide if you have to like fill in the circle or leave it open?
You fill in the circle if there's an equal to sign. You leave it open if there's not.
The thing that's been bothering me, what's the evaluate part?
Evaluate just means, like if I plug in a number for x, what do I get for y? And the evaluating is complicated a little bit because sometimes you plug it into one of them, sometimes you plug it into the other one.
I didn't know which one to do.
You look at the size of the number. So negative 50 is part of less than negative 1. So you plug it in the first one. You have to think about how big your numbers are and which inequality they fit into. So negative 50 is not greater than negative 1, so I can't plug it in there. Yeah.
Can you graph a piecewise function on a calculator?
You can graph a piecewise on a calculator, but it's really hard to type in. So I will show you guys how to do it, but we're not going to learn how to do it on first day. Yeah. So I'll show you so you can eventually check your answers. Honestly, a lot of students think it's not worth the trouble because there's a lot of typing involved when you plug them in. Okay, we're going to try an assignment. All right. We're going to skip the first one for a second. We're going to come back to it. But the quadratic is not in vertex form, and that's going to mess with your brain a little bit. So let's go ahead and do number 2. So how do we start number 2?
1.
Yeah, so you're graphing a line that starts at 1. And what should you do to get the next point? What's your slope? 2. So go up 2 over 1, up 2 over 1, up 2 over 1. So we started at 1, we did a slope of 2. And where do we draw our circle? At 1. Do we fill it in or leave it open? Fill it in. And are we keeping the right part of the line or the left part? X is greater than or equal to 1.
Right.
The right, that's the right side. X is greater than or equal to 1, that's the right side. And then we have a parabola. What transformation do you guys see on that parabola? Up 3. So there's the points that we use for a parabola. We just got to shift all of them up 3. So take your y coordinate, up 3, up 3, 3.
Oh man. Wait, no. See, stop talking when you want to.
What does continuous mean?
It means you can trace the entire graph without picking up your pencil. That is not a mathematical definition, but that's basically how you check it.
So this wouldn't be continuous right now. You have to go after that.
You'd have to, yeah, so the examples that we did in the video, well, we're still taking the video, but these ones, if you were to trace them, you'd trace this with your pencil, and you'd have to pick up your pencil to trace the other one, so you would say it's not continuous. They'd be continuous if this point and that point like overlapped each other. Yeah.
Is that like an important thing to get math?
They look at it. They look at it a little bit in pre-calc. You look at it a lot in calculus. Yeah. Okay, when I put the circle on the parabola, should the circle be open or should it be filled in? Should be open. And then what part of the parabola am I keeping? The left side. So I'm keeping this. And then this part gets erased. Okay. Now they're asking you about the domain, so they're saying what x values are you allowed to plug in? And right here they said you're allowed to plug in all the x values that are smaller than 1 and all the x values that are bigger than 1 and the x value that equals 1. So did they skip any x values? No, they didn't skip any, so what should we write? All real numbers. Or you can do negative infinity to positive infinity. If you look at the graph, what are the y values that you can see? 3 is the lowest y value, right? And then if you go up from 3, what other y values do you see?
All of them.
All of them. So how do we write that?
Y is greater than or equal to 3.
Y is greater than or equal to 3. What if you like to do the other notation?
Bracket with
I have a
3
question.
positive.
I have a question.
Yeah.
So, I thought that you said most teachers write it the second way in parentheses.
Yeah. Yeah. I think this is more common. That's been my experience.
Yeah.
But there's like certain contexts where you'll see inequalities more, like in piecewise functions, they typically put the inequalities there.
Could you also do parentheses instead?
You could also do, in a piecewise, you technically could do the brackets and parentheses, but I honestly have never seen it before. It's just like people just don't. All right. Is this a function? So if I use my pencil, does it touch 2 points at once?
Yes.
It does right there. Wait, but one of them is not actually a point, right? Because we didn't fill it in. So it actually does not touch 2 points at once. So that means yes, it is a function. When they ask if it's continuous, basically you just have to trace it with your pencil. And if you do not pick up your pencil to trace the entire thing, then it's continuous. So if I was to trace this, I'm tracing. I have to pick up my pencil and jump it over. So I would say this graph is not continuous because I had to pick up my pencil when I was tracing it. So continuous, a graph is continuous if you can trace the whole thing without picking up your pencil. So when I trace this, it's smooth, it's continuous, but then when I get here I have to pick up my pencil. And so we would say it's not continuous.
So I have a question, right? The entire time I think it's 2 functions. It's 1 function.
It's one function that has 2 pieces. Piecewise function. What happens if you plug in -2 for x? What do you get for y? You get -2, you get 7. What happens if you plug in 6? That's a little bit off the graph.
You get corrected.
Yeah, so you're going to have to plug it in up here. 6 is a value that's greater than 1, so this is where you plug it in. So we would say 2 times 6 plus 1 equals 13. What do you get if you plug in 1? 3. How come we shouldn't say 4? It doesn't actually equal it, right? So plug in 1, you get 3. Okay. Let's go back up to number 1 and do that parabola that's not in vertex form. So go ahead and graph that straight line. You could definitely do x plus 5. That's not bad.
You said you which one?
You can do the line, number 1.
That sounded nice.
Sneaky.
Are you good?
And where do we put the circle?
-2.
What? -2.
2. Do we fill it in or leave it open?
Which one is this?
It's open.
It's open. It doesn't equal, so leave it open. Are we keeping the left side or the right side?
Left.
Left side. Okay. What's the name of the form of this quadratic? We have three. We have vertex form, intercept form, standard form. It's standard. Do you guys remember the two things that we could easily get from standard form? Y-intercept and the vertex, yeah. So we're going to go ahead and find the vertex. We're going to find the vertex, and we're going to find the y-intercept. Does anyone know the y-intercept, just looking at it? It's 3. Yeah, you think about plugging zeros in for the x's, which would make both of them disappear. We got the point 0, 3. Okay. And then, do you guys remember how to find the x coordinate of the vertex? So negative 2 over 2 times 1, that's negative b over 2a. And so what is the x coordinate of our vertex? Negative 1. Okay. Do we remember how to find the y coordinate of the vertex? Plug it in. Okay, so negative 1 squared plus 2 times negative 1 plus 3. So the y coordinate of the vertex is 2. Okay, so we've got the point negative 1, 2. We have the point 0, 3. I'm going to go ahead and do one other point. I know that this point is going to get reflected over, so I'm not going to plug in negative 2. I'm going to go ahead and plug in positive 1.
Holy guacamole.
So 1, 2, 3, 4, 5, 6. Okay. And then I can go ahead and draw the other half of my parabola. Where'd you get lost? So we looked at this parabola and we could see that standard form. And we know that in standard form the two easy things to get are the vertex and the y-intercept. So the y-intercept is the number on the end, that's 0, 3. And then for the vertex we always did negative b, which is 2, so negative 2, divided by 2 times a, and the a value was 1. So this told us that the x coordinate of our vertex was negative 1.
And then you plug that in.
And we plugged it in, we got 2.
Okay.
And then when we were graphing those, you can find any point you want just by taking an x value and plugging it in. So I could see this is the middle of my parabola, 0's on the right side. I just picked another point on the right side. I picked 1 to plug in. I got the 0.16. And now I just kind of reflected it over because I know that they're symmetric.
Okay.
I know it's like perfect U shape.
Wait. Never mind.
So this one's kind of weird because if we draw a circle around negative 2 in the parabola, it's the same circle that we had from the line, and so now you're filling in a circle that was open before.
Oh.
Yeah. So the parabola filled in the circle from the line. And then what part of the parabola are we keeping? The right side. So I'm going to make the right side dark.
Oh, and it's continuous, right?
And I'm going to erase the left side. Yeah, and that made it, since the 2 points came together, that makes it so this graph is continuous. It is continuous. Okay. So, again, homework over the weekend is that review for the quiz Monday. However, I do want you to have number 1 and number 2 completely finished because I think you're capable of that. Okay? Is it a function? Yes, it passes the vertical line test.